Good morning and welcome to another episode of AI Buzz. I have some great stories to talk about today. AI solves the three-body problem faster. Talk about the Splunk CEO, Google's new biodiversity initiatives, and Hyundai's robotaxi service. I am your host, Nick, and welcome to another episode of AI Buzz. Let's get started. The three-body problem has been useful for sailors to solve for hundreds of years in order to determine their location at sea and in the water. The problem can be stated as follows. Identify the positions of three different bodies and then calculate their position based on a reference table of predetermined calculated positions based on your location and those three objects. Once you look at that table, you can then sort of pinpoint where you are. Each time the calculation is done, however, there is additional uncertainty in the measurement since one of the objects, or several of the objects that are typically used, would be the moon as well as celestial objects and others. And there's a sun that we have that provides warmth and we orbit it and all that, that actually, even though the moon orbits the Earth, the sun has a partial gravitational pull on it. And the fact that the sun partially pulls on the moon means that being able to predict your position with this approach for the future is one that is not always accurate. At the time, sailors did the best they could with this method, but exact positions based on that sun's pull on the moon were not always exact. Fast forward to the present day, we can reliably find our positions at sea, probably with our smartphones. Almost anyone can do it these days because everyone has a smartphone. Times have changed. The three-body approach is actually still used, though, by physicists for calculating the positions of celestial objects such as stars. Positions of these objects can still be determined with our computing power. We have tremendous computing power. However, it can still be very intensive in certain cases because there's black holes that kind of have the same role as the sun does on the moon, and back in the day, black holes can create pulls on the other objects that you might be looking at. So again, it can be done with today's computing, but it can be expensive, computationally expensive. So enter machine learning. A research group from the University of Edinburgh have created a deep learning model that can calculate positions of celestial objects by taking into account these black holes. How they tackled it was they solved the problem, their brute force method. So the method they currently use, which is they call the brute force method, it's called Brutus. This is considered a state-of-the-art brute force method. They used Brutus on 10,000, my mistake, 10,000 different scenarios. They had Brutus calculate solutions to the three-body problem 10,000 different times. And then what they did was they fed these solutions into a neural network. And then they exposed it to 5,000 new problems, 5,000 new scenarios of the three-body problem, and then compared it to the Brutus method. The group was led by a researcher from the University of Edinburgh, Philip Breen. He said that this neural network method was able to accurately solve the three-body problem for those 5,000 unseen scenarios. And so the researchers see the application, the final application of this stuff would be sort of a hybrid approach. For most cases, you'd still use the Brutus, the brute force method. However, if a problem becomes particularly complicated, the neural network approach could be activated and offers a great balance between computing as well as accuracy. If you don't want to throw all the computing sources you have at this problem, it's kind of a perhaps good approximation to the problem instead of going through the brute force method. And it actually turns out you can get a pretty similar solution, similar degrees of certainty with that neural network approach. It'll be much, much faster because it doesn't require all that just brute computation. Very cool stuff. Next up, there was an interview that Forbes did with the Splunk CEO. Definitely want to talk about this one. So Splunk is a data analytics software company founded in 2003. They've been around through a lot of evolving technology through the years. They've been acquired numerous times. Companies currently targeting edge devices, application development, cloud computing. They're trying to stay modern. They aren't the new kid on the block when it comes to software, data analytics, cloud, that type of stuff. So they're aware about what's going on in tech, to put it lightly. They're a pretty large and well funded, and they're one of the survivors of tech. So it was a particular surprise when in an interview by Forbes with the Splunk CEO, Doug Merritt, he said some interesting things. In addition to talking about how the company works with the cloud and future strategies, Mr. Merritt stated, AI does not exist today. Hold on a minute. What? AI does not exist today. So I guess that means that this entire podcast is completely unfounded, and I don't even know what I've been doing. I don't know what I've been reading about. I've been fascinated by a completely made-up field. Fortunately, though, it does not seem like Mr. Merritt meant that exact. I think he did not mean that literally, because he goes on to explain that it seems like he meant to kind of say that we don't have artificial general intelligence yet, which is of course true. However, we do absolutely have narrow forms of artificial intelligence, and these narrow forms can be applied to fields and have wide-reaching applications like computer vision and natural language processing. So to claim that just artificial intelligence does not exist today, it certainly turned some heads. It's really fired up some people, I guess, including myself. There's narrow forms of it do exist. But it will be some time before we have full artificial general intelligence. Exactly when that's going to happen, no one knows. Experts have their timelines, and those vary greatly. However, we do have forms of artificial intelligence today. Computer vision, natural language processing. We have the theory. We have these things being applied in practice in numerous fields. So I think it's safe to say that those narrow forms do exist. Next up, Google. Machine learning is being used to identify different species in nature. So even experts who are trained in certain subfields, such as mushrooms or some of these fields where there's thousands of different species that need to be identified, will have issues identifying all of them. Makes sense. Google AI research is going to great lengths to continue all of these nature lovers to do what they love and identify some of those cases where they don't know what they're looking at. And they've been working and building new tools and releasing them. So Google, at the Biodiversity Next conference, they've collaborated with several of the really sort of the leaders in and these are fantastic organizations, leaders in uh, kind of releasing nature tool. Let's see, what's a good term for that? Sort of tools that will enable people to, enjoy being out in nature and kind of when they see something they haven't seen before, allow them to identify it, perhaps provide some additional information on it, and just anything that's getting people out in nature, I think, is a great thing. So, in collaboration with iNaturalist and Visipedia, they've created a new tool for biodiversity research, which uses machine learning. The Global Biodiversity Information Facility, which Google has more than 1 billion different species that have been submitted by numerous organizations internationally. The GBIF, Global Biodiversity Information Facility, say that 5 times fast, will create package data sets. And one thing that they're doing that's really cool, I haven't noticed any other, maybe this is more commonplace than I think it is, but they've created DOI tags for these images within the dataset. So a DOI tag is used for citing in scientific articles. Most papers will have a DOI tag so that it's kind of a direct link to the article. It's not a URL, it's I don't know exactly what you'd even call it, but it's an identifier that allows you to cite things very easily, and it's kind of a universal citation method. So they'll release DOI tags for these data sets. Additionally, Google and Visipedia, they'll publish their trained nature models onto the TensorFlow hub. And these models will be made open source, which will allow them to be used in all sorts of different really cool nature-related projects that people will build. The original post by Google, I really recommend that you check it out, shows an awesome example of identifying fungi with the interactive mushroom recognizer. It's got to be one of the coolest names for a machine learning application. Interactive mushroom recognizer. They've released this on the TensorFlow hub, and this thing looks incredible. It has amazing user interface. People who are really into mushrooms, I think, are probably really into mushrooms, and I think they will just love this type of interface, as well as the vast amounts of data behind it, thanks to the Global Biodiversity Information Facility. So again, Google in collaboration with iNaturalist and Visipedia, doing some fantastic work in this area. Next up, Hyundai has been in the news recently for developing their enhanced smart cruise control technology. Now, they're hitting the news again with another machine learning development. They've released a self-driving system onto Hyundai Konas. It's one of their crossover vehicles. And this is going to be, it's been released. It's in collaboration with pony.ai, which I believe is a Chinese startup, and another startup called Via. So pony.ai, they provide ways to upgrade cars into becoming almost fully autonomous. Via is a popular ride-sharing service, and putting all 3 of these players together, the system apparently works rather well. So well, in fact, that all of these companies, they are collaborating on this new service called Botride, which is going to be a semi-autonomous fleet of robotic taxis. So they're not going to be completely autonomous, since there's going to be a human behind the wheel in all cases because of laws. But it's expected that it's almost completely autonomous now, and several years down the road, if we're able to drive cars without humans in them, could be a completely autonomous robotaxi fleet. So riders can book rides with Botride through a new smartphone app that's been released, and then they have to go to predetermined locations for being picked up and dropped off. So Via is they take care of the logistics aspect of this. Pony.ai is able to make these cars semi-autonomous, almost fully autonomous, and then Via is the one that's taking care of logistics, connecting the driver and the passenger. Hyundai is using the project to study the riding behavior of their customers and hopes to become one of the leaders in the emerging autonomous ride-sharing industry. Tesla has claimed similar goals. They eventually would like to have a fleet of 1 million robotaxis, according to Elon Musk. This is by the end of next year, I believe, unless I have my timelines mixed up. Seems like he's claiming a lot by the end of next year, but I won't go into that whole side story. Hope that comes true. But sounds like Hyundai, they've quietly become one of the first to market out of the major car manufacturers for this new next generation robotaxi thing. And I think the robotaxis are going to be, once they work well, that's of course going to change everything. People won't even have to really own cars. They can, just get shuttled around, and if you're not paying a human to, sit behind the wheel, then expenses are going to be lowered. And another thing is, if you do have a car, Tesla has stated that you can actually, when you're not using it, you can have this thing out delivering rides. So Hyundai, collaboration with pony.ai as well as Via, they are rolling out this new robotaxi service. Super cool. That's about all I have for you today on this episode of AI Buzz. Let me just do a brief recap of what we talked about. We talked about how AI is able to solve the three-body problem much faster than traditional brute force methods. So basically, AI is better than Brutus. Talked about some maybe controversial things that the Splunk CEO has stated about how AI does not exist today. Google's rolling out some cool biodiversity tools and data sets, as well as the DOI identifiers for easy citation of these images. And lastly, I talked about how Hyundai is one of the first to market in this new robotaxi space. Thanks so much for tuning in today on this episode of AI Buzz. Pleasure having you here. I will be back very soon, and I will let you know when I have more to talk about. It'll probably be tomorrow. Thanks for tuning in. Have a good day. Bye.